Alright, good day guys, how are you all doing? We're talking about the cyclic aliphatic hydrocarbons, and literally they are compound that deals with the carbon atom, which are bonded together in like a much more of a cyclic form or a fashionable manner. Let me just put it that way. So you have two categories as a basic level that as a basic line, let me put it that way. You have the cycloalkanes, and literally if you're someone who is used to organic chemistry, they would have actually tell you that you have what we call a saturated hydrocarbons and an unsaturated hydrocarbons. A saturated hydrocarbons is an example of alkane, a straight chain, a single bond all through the particular chain, all through the particular carbon atom. So while you have your unsaturated, you have the alkene and alkyne, right? So alkene possess a double bond. At least there should be a single double bond in the what, in the structure. An alkyne triple double bond, triple, a single, at least a single triple bond in the structure. There can be more. So when we talk about cyclo, things in a form whereby it is not more straight. Are you with me? So, and in that point, we have a straight chain, you have a branched chain alkane. So we're talking about a cyclic alkane. So literally we are putting it much more on the alkanes and alkane. So cycloalkanes is a particular saturated carbon that forms the ring also, and you have cycloalkanes as a particular carbon that also forms the ring of the cyclic aliphatic compound. But if that compound is saturated, then you are referring to alkane. If it is unsaturated, you are referring to alkanes. Are you with me? So when we talk about alkane, we usually put them in a way of saying they are monocycloalkanes. So monocycloalkanes usually have the same general formula with the open chain alkane. That's the straight chain alkane, which is CnH2n. And the cyclic compound started from n being equals to 3, which means that the first compound of a cycloalkane, a monocycloalkane, would be C3H6. Are you getting what I'm saying? C3H6. So, and literally most of them, it's not even most of them, their particular compound just differ from normal alkane with just less than 2 hydrogen atoms. And you get what I'm saying? So when you want to name some certain particular cyclic aliphatic hydrocarbons, or the rule is that you have to note something first is when all the carbon atom in a monocyclic hydrocarbon, they are saturated or they are unsaturated. Are you with me? The prefix cyclo has to be added to their group name, which is the ANE or the ENE. That's ANE for saturated, ENE for unsaturated. Saturated means there must be all the compound all through must have a single bond. And whenever you have a double, at least one double, as you can see here, in that point is no more an alkane, is what? An alkene. Are you with me? So if you are to name this now, we know the way we do name our normal alkane now. Say it is an alkane and it's a cyclic one, you have cyclo first. Then having cyclo, what do we possess? It has 3 carbon atom, which starts from what? Propane. So you have cyclopropane. The next one, you have how many carbon atom? 4. So therefore you have what? Cyclobutane. Alright, this is just like a normal basic naming of them. Then literally having this now, if you have to look at, is a direct naming, but you have 4 carbon atom there, which forms what? Butene, not butane, because of what? The double bond, but one in. So you have cyclobutane. So let's move on to some little particular rules. The advanced rule of naming some other compound whenever you see them. Alright, so let's look at the second rule. The second rule is that if you have a particular single substituted cycloalkane, that's if you have like a substituent, which is a single one, it's actually named without indicating the position of the substituent. That's for cycloalkane. And the carbon atom in the ring are numbered in such a way that the lowest possible number must be assigned to what? To the substituent. Just like the way we do give the normal, what do they call it? The normal alkane naming. So starting with one of them. Now, the third rule tells us that an unsubstituted cycloalkane also, the other one we talked about the other time was an unsubstituted one, which was cyclobutane, unsubstituted. We name it without indicating the position of the double bond. You don't need to indicate it. Now, but if it has one or more substituents, Numbering starts from the what? From one what? The doubly bond. Are you get what I'm saying? So from the one, from one of the what? Of the double bond. Now from one of the double bond. Now at this point now, what they mean is that you must count those double bond literally first. But look at what we are trying to explain. We'll come back to this. From one of the double bond carbon atom in a direction in which the substituents are assigned the lowest possible numbers. Now if you have to look at this now from this example, if you have to name this, we know automatically this is a alkane, right? And if you have to look at the structure, you have 1, 2, 3, 4, which makes it a butane. So, and what do we have here? We have methyl, a substituent. Like we said now, you can say you have 1, 2, 3, 4. Literally, you can call this one methyl cyclobutane. Are you get what I'm saying? One methyl cyclobutane, or literally you can just say methyl cyclobutane, because you don't usually need to assign the numbers to it. You get what I'm saying? Because it is just a single substituent. That was what they told us here, without indicating the position of the substituents. Then, because one methyl cyclobutane, just like you saying methyl cyclobutane. Now, looking at this now, do not forget, from naming of compound, are you with me? Naming of compound follows alphabetical order. That is, your C comes before your M. This chloro, this is methyl. So irrespective of how you position them, the naming must follow an alphabetical order. Put that at the back of your mind. Now, from this, while counting from this, if you have to look at, we are going to be starting from the one closest, numbering the closest aspect of it. And it says here that the carbon atom in a ring are numbered in such a way that the lowest possible number are assigned. Now, if I want to start my counting from here, if I want to start I have 1, 2, 3, are you with me? 4, 5, 6. This starts from 1, so this starts from 3. Are you get what I'm saying? Then if I'm to start from here, I have 1, 2, 3. Are you get what I'm saying? So at this point now, why would I start from? You have to understand something, that chlorine has more rank than methyl. Are you get what I'm saying? It has more rank than methyl in the sense that I will start from chlorine. Chlorine being an heteroatom, I start from chlorine before moving to what? To methyl. So counting at this rank now, I have 1, 2, 3, 4, 5, 6. So I'm going to be having what? 1. I have dichloro. Are you with me? Dichloro, then 3 methyl. Then what do we have? Cyclo. What? Cyclo. We have 1, 2, 3, 4, 5, 6. So you have cyclohexane. You have cyclohexane. Are you with me? So when you are dealing with double bond breaks the theory, because at that point double bond is basically talking about his own bond, nothing concerning with all these things that are there. His own bond needs to be counted first. So whatever he now wants to count, it depends on two categories. That if I'm to count, from here or I'm to count from here. So I'm to count from here, I have 1, 2. I must count through the double bond. I can't count by this 1, 2, 3. That's the wrong counting. So I have 1, 2, 3, 4, 5. And don't forget, lowest possible number is very important. If I'm to count towards this side, 1, 2, 3, 4. Bromine is in 4. Methyl is in what? 5. If I'm to count throughout this place, 1, 2, 3, 4. You can see that methyl is in 3, bromine is in 4, which is what? I have to count throughout this place to make it much more easier. So I have 1, I have 2, I have 3, I have 4, and I have what? 5. Are we there? So, and it's the double bond. So literally, this is the 5 carbon atom. That is what? Pentene, right? And do not forget alphabetical order. This is what? A 4 bromo. A 4 bromo. Then what? I have 3 methyl. 3 methyl. Cyclo what? Cyclopentene. So literally, I do urge people that before you move into naming of all these kinds of compound, understand the basic aspects of all these organic compound first. How do you name alkene normally? How do you name alkene and alkyne normally? Straight and branch before you start moving into all these ones, because it's just like you utilizing the same rule for those ones, but just in a more advanced way. Imagine you skipping junior secondary school, then instantly move to secondary school to learn the normal work they are doing there. You would have issue. That's the same thing how all these structures are. Go back to the normal beginning aspect. Do not rush, so you can understand some of them. Thank you.